Assalamualaikum. My group title is Urban Mobility UAM Integration in Selangor. Our group member is Afrina Shafia binti Azmi, Nofara Amira binti Muhammad, Amy Zuhaira Diana binti Zuraidi, Abdul Fattah bin Abdul Kadir, and the last one is Sarif Muhammad Daniel bin Sarif Rosli.
Urban Air Mobility UAM represent a transformative concept in transportation aiming to integrate advanced aerial vehicles into urban environments. This initiative seeks to alleviate traffic congestion, reduce emissions, and enhance mobility through efficient, autonomous, and environmentally friendly air vehicles. As cities grow and face increasing transportation challenges, UAM promises to revolutionize how people and goods are transported, offering faster and more flexible alternatives to traditional ground-based transport system. This introduction sets the stage for exploring the potential benefits and challenges associated with the integration of UAM into urban landscape. Urban air mobility integration faces several challenges such as technical challenges, airspace integrations, and regulatory framework. The firstly is technical challenges. The first point is battery technology limitations. UAM vehicles rely on electric vertical takeoff and landing (eVTOL) aircraft, which require significant advancement in battery technology for efficient and long-duration flight. The next one is infrastructure development costs. Establishing vertiports and supporting infrastructure is costly and requires significant investment. The next one is airspace integration. The first point for it is airspace allocations. UAM operations need to be integrated into existing airspace, which poses challenges in allocating airspace and managing interactions with other air traffic users. The next one is demand on human operators. UAM operations require modifications to air traffic control system and increased workload for controllers. The last one is regulatory framework. For the first point is existing aviation regulations. UAM operation must comply with existing aviation regulation, which can be restrictive and require novel policies for urban area transport. The next one is interoperability. UAM vehicles need to be designed for interoperability with other airspace users, including general aviation and commercial aircraft.
In an era marked by rapid urbanization and increasing demands for efficient transportation solutions, the integration of urban air mobility presents a transformative opportunity for Selangor, Malaysia. The Urban Mobility Integration in Selangor project aims to revolutionize public transport infrastructure by leveraging cutting-edge technologies to enhance efficiency, sustainability, and connectivity across the region. The first aim is to enhance public transport efficiency, implement a network of eVTOL aircraft to provide rapid transit options between key and urban areas such as Petaling Jaya and Shah Alam, reducing travel times from over an hour to just 15 to 20 minutes during peak traffic hours. The second aim is accessibility and connectivity. By developing vertiports in suburban areas like Puchong and Subang Jaya, ensuring residents have direct and fast access to urban centres, thus enhancing the connectivity of public transport across Selangor. The third aim is sustainability. Introduce a fleet of zero-emissions eVTOLs powered by renewable energy sources like solar and wind, contributing to Selangor's goal of reducing carbon emissions by 30% by 2030. Moving on to the objectives of the project. The first objective is pilot urban air mobile network implementation. Establish a pilot route connecting KLIA with key business districts in Selangor, such as Petaling Jaya and Shah Alam. This will involve constructing vertiports at strategic locations and launching a fleet of eVTOL aircraft to demonstrate the feasibility and benefits of UAM. The second objective is environmental impact reduction. Deploy a fleet of electric-powered eVTOLs that run on renewable energies, such as solar charged batteries, to ensure zero emissions during operations. This will contribute to Selangor's green initiative and targets for reducing transportation-related pollution. The last objective is seamless multimodal integration. Develop a unified ticketing system and mobile app for ease of access and coordination among different transport modes.
And now I'm Batisha. We talk about scope of the project, area, services and operation. For area, we cover Shah Alam, Petaling Jaya, Subanjaya, Kelang, Cyberjaya and Putrajaya. These areas are selected for their economic significance, population, density and potential to benefit from reduced ground traffic congestion through UAM solution. For services, the UAM services to be integrated into Selangor will include passenger transport, cargo delivery, medical and emergency services, surveillance and security. For operations, the operational framework for UAM in Selangor will encompass vertiports and landing zones, air traffic management ATM, regulatory compliance, public-private partnership PPPs, safety and security protocols, and community engagement. And the last one is sustainability initiatives.
So, for the part of literature review, in the Journals of Urban and Mobility, a comprehensive review and comparative analysis with autonomous and electric ground transportation for informing future research. The article says urban air mobility, also known as advanced air mobility (AAM). The growing interest and research in the UAM over the past 5 years is evidenced by the rapid increase in the publications. The article conducts a comparative review and analysis over the 800 publications related to the UAM, and the main findings from the meta-analysis shows that UAM research is evenly divided between aircraft technologies topics and market topics. So here's the sketching plan. So here's the solution and approach. Urban air mobility solution as a part of the public transport network to alleviate congestion, enhance connectivity, and provide efficient and sustainable transportation options urban areas in Selangor. So the successful integration of UAM in Selangor requires a comprehensive approach, including the development of necessary infrastructure such as vertiports and charging stations. Collaboration between government, private sector stakeholders, and international experts is essential to overcome the challenges and optimize the benefits of UAM.
So I will present to you about the technology method we use. So first of all is vertical takeoff and landing aircraft. So it designed to take off and land vertically. This makes them suitable for the urban areas where space is constrained. Second is sustainable energy solution. So its utilization of a sustainable and renewable energy sources to power UAM vehicle by reducing their environmental footprint. The next is regulatory framework and safety standard. So it established of regulation and safety standards to govern UAM operation and ensure a public safety. So let's move to the time frame. The first year initial planning and feasibility study. Next, for year 2 to 3, we design and prototype development. Other than that, for years 4 to 5, infrastructure development and pilot programs. Next, for the years 5 to 6, regulatory approval and public outreach. Next, for years 7 to 10, full-scale implementation and expansion. Lastly is uh, continuous improvement and innovation will be year to year 10. Estimate budget of the project. Initial planning and feasibility studies, it goes to 4.5 million. Design and prototype development, it goes to 75 million. Infrastructure development and pilot program, it goes to 150 million. Regulatory approval and public outreach, it goes to 50 million. Full scale implementation and expansion, it goes to 400 million. Continuing improvement and innovation initial for 5 years, it goes to 375 million. For the grand total is 1.0195 billion ringgit.
For benefit, the projection of ridership, we have increased accessibility by UAM services can provide faster and more direct routes compared to traditional ground transportation. And then we have convenience and time savings. With UAM, travel times can be significantly reduced. The market demand, especially business travelers and high-income individuals, are likely to adopt this mode of transportation. And the last one is tourism boost. UAM can enhance the tourism industry by providing quick and scenical aerial routes to popular tourist destinations within Selangor. For the environmental issues, we have reduction in emissions by electric vertical takeoff and landing (eVTOL) vehicles, which are commonly used in UAM product zero direct emissions. For noise pollution, advanced eVTOL designs are significantly quieter than traditional helicopters and airplanes, which can help mitigate the noise pollution in urban areas. For sustainable urban growth, by reducing the reliance on fossil fuel power vehicles, leading to cleaner air and healthier environment. For the traffic flow improvement, we have elevating ground traffic congestion by diverting a portion of the commuter load from roads to the air. And then the emergency services, UAM can provide rapid response option for emergency services such as medical evacuation and disaster response, which can bypass ground traffic and save crucial time. And the last one is infrastructure optimization. UAM can complement existing public transport system by providing last mile connectivity.
In conclusion, the integrations of urban air mobility holds tremendous potential to redefine urban transportation system. By leveraging advanced aerial technologies, UAM promises to alleviate traffic congestions, reduce carbon emissions, and enhance overall mobility efficiency. However, realizing this benefit requires addressing various challenges such as regulatory framework, infrastructure development, public acceptance, and safety concerns. As stakeholders continue to collaborate and innovate, the future of urban air mobility (UAM) appears promising, offering cities around the world an opportunity to embrace a more sustainable and interconnected transportation ecosystem.